Hi everyone. Today our goal is to learn how to make a box plot and what the heck the IQR is. I have a little kitty here, super cute little kitten. The reason for that is because box plots are sometimes called box and whisker plots. So here's some cute little kitten whiskers for you. You're welcome. All right, so what is a box plot? Well, we use it with simple data sets, and they are especially useful when the data is skewed. Okay, you guys remember what they look like, I'm sure. This is an example of one right here, and we'll talk about what all those things are. Those are the 5-number summary, all those things that were being pointed to, and it is used, the 5-number summary is used to describe the data set. You need the 5-number summary in order to draw the box plot. Okay, so the box plot it utilizes the 5-number summary in order to be created. The 5 numbers are the minimum, Q sub 1, the median, Q sub 3, and the maximum. So I'm sure you're familiar with some of those, and you probably should know all of them from last year, but we'll give you a reminder in case you don't. Obviously, the minimum is the smallest number in your data set. The median is the middle number. We went over that in 4.1 here. And the maximum is your highest number. Q1 and Q3, what are those? Down here. Q1 is the first, or also it's sometimes called the lower quartile. So that is your Q sub 1. Q sub 3, your third, or sometimes called the upper quartile. That's the point at which 75% of the data occurs. Okay? The interquartile range, this big IQR, if you take Q3 minus Q1, that'll give you the middle 50% of the data. So if you're working with Q3, you have 75% of the data. If you subtract off the Q sub 1, that's 25% of the data. So that would obviously leave you with 50%, and it's right there in the middle. Definitely pause and write down these definitions along with those first ones if you didn't get them. So if you look at what you have here, you have the smallest number, 25% of the data, the middle number, the the third quartile gives you 75% of the data, and then the highest number. So it's just kind of like taking all that data and splitting it up into quarters, right? And if you look at the interquartile range, that's here, from here to here, the middle 50% of the data. Okay, so pause as needed to get, or rewind to get all those definitions. All right, so we have some data here. We have the 2016-2017 Golden State Warriors and the total number of points scored from each player on the roster. We're going to just look at that. We're not going to look at the games played. So we're only looking at this column of data. Okay, here's some basic definitions for constructing a box plot by hand. I'm going to walk you through that. All right, so first of all, you have all of this data. Ignore this down here for a second. Because in the list that was given to us, these are not in order. And we know when we're working with this data, we always want to put it in order. Okay, so you could do that by hand pretty easily and come up with this list of numbers. All right, you also know how to do it in your calculator. I have already shown you that in the last video. You could also type these in and have the calculator sort it. That is fine. Okay. All right, we want to make a horizontal box plot, of course horizontal going this way, and that is typically how we see box plots. You can do them vertically as well, but that's less common. And you could still use these directions, just would be vertical. All right, step 1, draw a number line. Well, better have my number line going here. I'm going to add a scale that begins at or below the minimum and ends at or above the maximum. Well, my minimum, since I ordered them, is 135. My maximum is 1,999. So I'd say probably if I could go from 0 to 2000, I'd probably be pretty good. Okay, and then I just kind of want to chunk that a little bit. So if I cut it right in the middle, that'd be 1000. In between that would be 500, and over here would be 1500. That's probably pretty good. You certainly don't want to label every single number. You don't even need to label as much as we would label on, say, a coordinate plane. Okay, this is fine the way it is. Sometimes students want to use the exact numbers, like 147, they would, or 135, I'm sorry, they would stick here, and 1999 stick here. You don't want to do that. You want to keep it kind of extending above and below the minimum and the maximum. All right, so that was step 1. Step 2, directly above the number line, draw a rectangular box that extends from Q1 to Q3. Divide the box with a vertical line at the median. Well, that means we need to find all of that stuff. We need to find the median, and we need to find quartile 1 and quartile 3, where those would be. Okay? All right, so let's start with the median. There are 13 numbers in our data set. You can count them, double check that. But if you've got 13 numbers, that means the median, there's going to be 6 numbers on one side, 6 numbers on the other, and the one right in the middle is going to give you your median. So 1, 2, 3, 4, 5, 6. This should be our 1. Let's double check. 1, 2, 3, 4, 5, 6. Okay, so 470 is the median. So we want to have a vertical line for that. So 470, kind of got to eyeball it here. So here's about 500. It's going to be a little bit less. Here's my vertical line. Okay. Then you also want to mark, oops. Okay, so that was the median, and then to find the first quartile, the lower quartile, it's all you're going to do is find, here's your median, let me mark that. All you're going to find is the median of that first half of data. All right, sorry, I got interrupted and I have no idea where I was. Finding the first quartile, I think. Okay, so once you find your median, you're not going to use that data anymore. So we're going to say that this is the first half of the data, and you want to find the median then of that first half. That's how you find your lower quartile. So there are 6 numbers in that lower half, so your median would be the mean of your middle 2 numbers. So you would take your 284 plus 313, and then we know we want to hit enter, then divide by 2, or use parentheses around the addition. Now we don't want 597 over 2, we want to figure out what that actually is, so you could hit 597, divide by 2, control enter, to get 298.5. So 298.5, that is your first quartile. So you want to do another vertical line there. Here's maybe 250. It's a little bit more than that. Okay, so there is your first quartile. Now you want to do the same thing for your third quartile, your upper quartile. So you're going to use the second half of your data. Again, you ignore the median. So we have 6 data points. So it's going to be halfway between your 2 middle numbers, otherwise known as the mean of those. So again, in our calculator, now we need to do 776 plus 1555, enter, and then divide by 2. And because I know my calculator is going to give me a fraction, I can immediately hit control enter, and we get 1165.5. So that is Q3, so a little bit more than 1,000. Maybe about here. Okay, and now we want to create a box out of those lines. Okay, so I'm topping my box off. You can put a bottom one on it here, or you can actually just make it touch the number line. I personally kind of like to actually have the box. Okay, that was step 2. Step 3, draw 2 whiskers, one from the middle left side of the box, so right here, to the minimum. Our minimum is 135, so we need to mark that. and then draw your whisker over. And then do the exact same thing with the maximum. Our maximum is 19.99. And draw your whisker over to there. Okay, so this is our box and whisker plot for this data. So what information do we know from here? Well, we know that this is the minimum, this is the maximum, this is the median, this is quartile 1, and this is quartile 3. So what that is telling you is that, well, let me actually show you this picture. Same idea here. This is a very symmetrical box plot, but each part contains 25% of the data. So that means this piece here has 25%. This piece here has 25%. This piece, 25%, and this piece, 25%. Now, if you have symmetrical data, your box plot should look very similar to this. But if it's skewed, it's not going to be so nicely perfect. It's going to be pushed over like this one is. Okay? So you can see that you have, remember, these all contain 25% of the data. So this 25% of the data and this 25% of the data is relatively, the numbers are close together. But the next 25%, look at how much more spread out those numbers are. It still has the same amount of numbers in it, the same amount of data points in it. It's just that your numbers are further apart. And the same goes for your last 25% of your data. They're very spread apart versus how small these ones were. Okay? Okay, example, create a box plot of the distribution of points scored by the 1997-1998 Chicago Bulls using the following 5-number summary. So the star player for Golden State last year, of course, was Stephen Curry. Anybody know who the star player is for the 97-98 Bulls? Little guy named Michael Jordan, maybe you've heard of him. So we've already analyzed the data and we've come up with our 5-number summary. So I want you guys to draw the box plot for this information. Do it on the same box plot. Do it right above this box plot. So I want it right up here. Okay. Use the same scale. Don't change any of that. Go ahead and pause the video and do that now. Okay, compare what you have to what I have. The data is shifted just slightly more to the right for as far as the maximum and the minimum. The first quartile is almost exactly the same. The third quartile is a little lower, and your median is a little lower. So the purpose of doing these box plots is A, to get the data to see what the distribution looks like, but also to compare data, to compare like 2 different data sets. So that's what we're doing in this example. Okay, moving on. Oops, maybe not. All right, example, Bean goes fishing. He catches 16 fish displayed by their length in the stem plot below. Remember, this is a stem and leaf plot, also known as a stem plot. And what we want to do is take the information off of it and create a box plot. And on this one, I'm going to show you how to do this in your calculator. So if you are at home watching this video, follow along, write down steps of what I'm doing, and then when you come back to school, you need to make sure you pick up a calculator and actually do this. Some of you guys on the last section were saying you never did the standard deviation in your calculator, or even in the last chapter saying you never learned how to solve a system by graphing in the calculator. Anything I'm showing you in the calculator, you need to be able to do. So if you are watching a video not at school, or you don't have access to a graphing calculator, you need to do it when you come back to school. Ideally, you should have bought a graphing calculator, the same one we use in class, to use at home. But if you don't have that, then you need to be making sure you're doing it during class. Along with that, it is imperative that you know how to do this stuff in your calculator, because when we take the end of course state tests, you are allowed to use your calculator, and everything you do will be so much easier if you do it in your calculator. If you try to do everything by hand, you might run out of time, or you might forget how to do it. So take advantage of the calculator, that it's going to do work for you as long as you know how to use it. Okay, so I'm going to show you some stuff that we've never used in the calculator today. So go to your home screen, and normally we are either in calculator graph, but today I want you to go to new document. So option 1. If it were to come up and say something about an unsaved document, you never need to save any of this stuff. So click no, that would be fine. Okay. Then we want to click option 4, add lists and spreadsheets. Previously I showed you how to type a list in just using the brackets. This is a different way to do it. First thing you want to do is give it a name. So click up in this A box and you can name it anything you want. I kind of just generally stick with X, but you could use any variable you want. Maybe this time we'll use F for fish, because this is the number or the lengths of fish that he is catching. This equals, we don't want to use that, so you can leave that box empty. Okay, and then we're just going to start typing our data in. So our key is that this would mean 10 inches, so this first one would be 7 inches. Arrow down to get to your next one. We have another 7, 8, 9, 9, 9, 10, 10, 12, keep going. So type all your data in. And then it's a good thing to check and make sure that you have the right number of data points in there. This says this is row 16. We started with row 1, so that means we should have 16 numbers in here. So you can count these up real quick and make sure. And sure enough, there are 16. Okay, so we have a list of numbers. We named that list F. Everything is in there. Okay, now what we need to do is figure out all that information about them in order to create our box plot. So we need our 5-number summary. What's nice is that your calculator will do it for you. So right from where we're at, you want to hit Control Doc. And if you look at that above doc, it says plus page. So we're adding a page into this document that we've created. In this case, we want to choose option 5, add data and statistics, because we're talking about analyzing this data here. Leave this alone for a second and then hit Control Add Page again. And this time we want to add calculator. Okay, so those are the 3 things you're going to need. So we started, to show you again, it's Control Doc. And then we started with lists and spreadsheets. You need a data and statistics, and we need a calculator. So those are the 3 things you'll need here. And you can see each one has their own tab. This one I don't need because I was just showing you. So, and then you can arrow around, mouse around to switch between them. Here's your lists and spreadsheets. Once you type your list in, you're going to be done with that. We're going to come back to this one, and in your calculator screen, press Menu, Statistics, and then Stat Calculation. So if I were you, I would be writing down these steps. So next time you go to do it on your own, you know how. So Menu, Statistics, Stat Calculations. Sorry, I hit something wrong. Menu, Statistics, Stat Calculations, and we want the very first one variable statistics, because we're talking about one variable. We don't have 2 things, we don't have 3 things. We're just talking about how many fish there are. That's our only variable. Not how many fish, the size of the fish. We're only going to have 1 list of data. Click OK. And what was that? What did we name that list? We named it F. So type F in. You don't have to change anything else, and click OK. And it spits out all this crazy looking data. Okay? You don't need most of these numbers, you only need some of them. First of all, this X bar is actually your mean. Okay, so I think I wrote that down on the bottom right here. So technology help, that X bar is actually the mean. So last couple sections ago, I showed you how to find the mean in your calculator a different way. Here's a second way to do it. Along with that, the next thing you could find useful is this SX. That's your standard deviation. It's not S sub X, it's just SX. So you might want to change that on your notes there. Okay. And then if you keep going down, you're going to find your 5-number summary. Helps if I pull the right thing up. Your 5-number summary is right here. Minimum, quartile 1, median, quartile 3, and your maximum. Okay, so there's other numbers in here that you don't need to worry about. So it's just X bar is your mean, SX is your standard deviation, and then you've got your 5-number summary down here. Okay, so we're going to use this information and we are going to make our box plot. Okay, so we don't need to look at our stem and leaf plot anymore. We can use this data right here. We would start with our median. Well, I guess you start with your number line, but then plot your median, plot your quartile 1, quartile 3, plot your min and your max, and make your box, just like we did in the last one. The only difference is now you don't have to find the numbers. The calculator will do it for you. However, in addition to this, the calculator will also actually make your full box plot. So if you go back to that, if you go to that one that we skipped, we can turn this into a box plot. Okay, so first you want to click here on the bottom and we want to call that variable, we want to tell that that's f. Now mine, it came right up. If yours wouldn't do that, I think you can just type it in. But I think it knows that f is our only option, or if you called it something else. But if you have more than one list in there, you might have to choose what you're actually calling it. Once you do that, it creates a basic dot plot. We don't want a dot plot though, we want a box plot. However, last section you were asked to find dot plots, so now on your test maybe you could actually check your work with it by doing it this way. Because we're only working with one variable, we don't want a second variable over here. Okay, then you're going to click menu, plot type, and this is where you're going to change it into a box plot. So menu, plot type, box plot. It moves the dots, look at that, change it right into a box plot. Okay, it sometimes leaves off these, like the actual vertical line for your minimum and your maximum, but I don't think it would be too difficult to just draw those in on your own. So at this point, let me pull that over here. If you compare your information that we have, the calculator told us the minimum is 7. Sure enough, that looks like 7. First quartile's at 9, median's at 11, third quartile 16, and the maximum is 22. Okay, so you could very easily now just copy this information down and draw your box plot. So the calculator will do everything for you. It will find the 5-number summary and it will draw your box plot for you. And in fact, if you mouse over on your calculator screen using this little sensor right there, it will show you, the numbers will pop up and it will even label what they are. Median, quartile 3, quartile 1. It doesn't tell you minimum and maximum, but it will give you the numbers. Pretty neat. Good use of technology here. It will save you a lot of time if you do it this way. You should know how to do it both ways. All right, answering some questions. Find the IQR. Well, the IQR, remember, is just quartile 3 minus quartile 1. Quartile 3, whether you're looking here or in your information here, is 16. Quartile 1 is 9. So the IQR is 7. Between which two values is approximately 50% of the middle data contained? Well, the middle 50% of the data is the IQR, so it would be between 16 and 9, or between 9 and 16. Find the range of the data. The full range would be the maximum versus the minus the minimum. Your maximum is 22. Your minimum is 7. 22 minus 7 is 15. What percentage of the fish were greater than 9 inches long? So greater than 9 inches. Here's my 9 inches. So greater than that would be all the data this way. Well, I know that each section of this contains 25%. So the only thing that is less than that, that wouldn't fit in this question, is this part right here. and that's 25% of the data, so approximately 75% are greater than 9 inches. What percentage of the fish were greater than 7 but less than 16? So greater than 7 here, less than 16 here. So I'm looking at the data that's between those two numbers. And you don't need to make all these scratch marks. I'm just showing you what I'm looking at. Well, the only thing that doesn't fit in there is that last whisker. That last whisker represents 25% of the data. This is 25. Another 25 makes 50. Another 25 makes 75. We exclude the final 25%. So that would be 75%. And that should make sense because what we looked at was they both had 3 pieces in common. Or they both had 3 pieces, not in common, but they both had 3 pieces for part D and part E. Okay, a little more of that technology help. One thing I didn't show you was the Zoom stat. This is for a different calculator, so it's a little different. But if you go to your data screen, if you go to Menu, Windows Zoom, Zoom Data. So ours isn't the number they gave. Ours, this one's already good, but say your data, you had like a really crazy outlier, that could move it around to help you see it better. But in this case, it didn't actually change it. It was already good to go. So it's not 9 there. It was whatever number that happened to be. All right. Any questions? Hopefully not. If you have them, though, please jot them down so that we can talk about them during class. Otherwise, keep moving forward on your packet.